So now let us look at some miscellaneous identities. The first is 2 sine inverse x. 2 sine inverse x is equal to sine inverse of 2x into root of 1 minus x square. Again, the formulas look very close to your trigonometric formulas. So what is the formula for sine 2 theta? 2 sine theta cos theta. 2 sine theta, this is something like cos theta, which is root of 1 minus sine square theta. So 2 sine inverse x is equal to sine inverse of 2x root of 1 minus x square. This formula works as long as x is less than or equal to 1 by root 2. The meaning is, if x is less than or equal to 1 by root 2, this will be less than or equal to pi by 4 into 2 will be less than or equal to pi by 2. Again, the same condition. If this complete expression is less than pi by 2, the direct formula works. If this expression is greater than pi by 2, so this expression cannot give you that value. And if you draw the quadrant diagram for sine, plus plus minus minus, so if this number is greater than pi by 2, so the LHS will be some value which looks like this. Now what does this formula give you? This formula gives you an allied angle in the range of sine inverse. So what is the allied angle to this? On the positive side, so this is positive. So this should be the answer which is given by this. So the LHS is this angle, the RHS is this angle. So what should you do to make this angle into this angle? Obviously we know that if this is theta, this will be pi minus theta. So suppose this angle is 2 pi by 3. This formula will give you pi by 3. And if you do pi minus pi by 3, you get exactly the same number. Similarly, 2 cos inverse x is equal to cos inverse of 2x square minus 1. And this formula is valid for all positive x between 0 and 1. You can see why. When x is positive, cos inverse x is in between 0 and 90 degrees. So 2 times this is in between 0 and pi, which lies completely in the range of cos inverse. So cos inverse can give you any value in between 0 and pi. So you don't need any extra cases. So 2 cos inverse x is always equal to cos inverse of 2x square minus 1. Again, do you see some similarity with the trigonometric formula? Cos 2 theta is 2 cos square theta minus 1. 2x square minus 1. Next, for all x belongs to positive real numbers, 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square if x is less than or equal to 1, pi plus this if x is greater than 1. Again, if x is less than or equal to 1, tan inverse x is less than or equal to pi by 4, 2 tan inverse x is less than or equal to pi by 2. So if x is less than or equal to 1, this number will be acute angle, hence directly this formula can give you the answer. 2 tan theta by 1 minus tan square theta. Now if x is greater than 1, this number becomes more than pi by 2. So if you draw the quadrant diagram for tan inverse, plus minus plus minus. Now if the LHS is more than pi by 2, this formula will give you an allied angle. So negative side, you have to go to negative side, means this formula will give you this angle. For example, if this total angle is 2 pi by 3, this formula will give you the allied position in the fourth quadrant, is minus pi by 3. So what should you do to minus pi by 3 to make it equal to 2 pi by 3? Pi minus pi by 3. So if you add a pi minus pi by 3 will become 2 pi by 3. That is how you equate the LHS and RHS. So inverse trigonometric identities involve this basic manipulation of the formulas depending on where the angle lies. So I hope you understand all this formula. Next, 2 tan inverse x, as we have seen, is equal to tan inverse of 2x by 1 minus x square if x is less than or equal to 1 and x is positive. So 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. Now, in this case, this tan inverse can be converted into cos inverse and sin inverse using the triangle method. So if you use the triangle method, this is alpha, this is 2x, this is 1 minus x square. So by Pythagoras theorem, if you calculate the hypotenuse, it will turn out to be 1 plus x square. So tan inverse of 2x by 1 minus x square is equal to sin inverse of 2x by 1 plus x square is equal to cos inverse of 1 minus x square by 1 plus x square. And these straightforward formulas will be valid as long as x is less than or equal to 1. That is, this angle is in between 0 and 90 degrees. Now, if x is greater than 1, the LHS will become more than 90 degrees. That is, from 90 degrees to 180 degrees. So, sin inverse and tan inverse cannot manage these numbers. Cos inverse can manage. So, the formula with respect to cos inverse does not change. Cos inverse can give values between 90 and 180. So 2 tan inverse x is equal to cos inverse of 1 minus x square by 1 plus x square works. Next, what should you do for sin inverse? So the LHS, so this is the quadrant diagram for sin inverse. The LHS is an angle in the second quadrant. So if you consider sin inverse, what is the angle that this gives? This formula gives you the corresponding angle to this angle within its range. So what is the corresponding angle for this ray? This ray, because plus has to go to plus. So 2 tan inverse x, because this lies between 90 and 180, this formula will give you this. So to bring this to this, so you have to do pi minus of this angle. If this angle is 150 degrees, this will give you 30 degrees. If this is 150 degrees, this will give you 30 degrees. So how do you make 30 into 150? Pi minus 30. Similarly, if you go to tan inverse, the LHS is the second quadrant. So what is the quadrant diagram for tan? Plus minus plus minus. So now tan inverse of 2x by 1 plus x square will give you the corresponding angle to this ray in the range of tan inverse. So minus has to go to minus. So this formula will give you this angle. So what should you add to this to get this ray to this ray? You have to add a 180 degrees. So this plus pi is the answer. So I hope you are understanding the manipulations that are involved in deriving the formulas. So if you understand these simple manipulations, you don't need to remember a lot of formulas. So the basic formulas, if you remember, you can do the manipulation depending on where the LHS lie. So this is the beauty of inverse trigonometric functions. So that's why many students feel it difficult to do these manipulations. So if you understand the basics of the domain and range of the inverse trigonometric functions and the quadrant diagrams, it is quite simple to derive all these formulas. Personally, I don't remember these formulas. So I only remember these simple formulas. And whenever you have problems with the range, just need to add or subtract a pi, add a plus or minus sign, so on. Now let us go and solve few examples before we conclude this topic.